Hi guys, this video is going to continue to talk about the concepts of torque and rotational motion. In this video, we are specifically going to be talking about the center of mass, also known as the center of gravity. Those two phrases, the center of mass and the center of gravity, really mean the same thing. We might be using those phrases interchangeably. There is a formula that you can use to find the center of mass, and if we take a look at it, in the numerator, we have the mass times the distance plus the mass times the distance, etc. This is essentially torque. The only thing that's missing is gravity, but since gravity is going to be the same throughout, that's just not included in this equation. So it is essentially the same thing we've been doing, mass times distance, as we would do for torque. And then in the denominator, we divide by the total mass of whatever our system is. So let's take a look at how to do that. This sentence, number one, goes with this diagram. So if we have 1.10 kilogram mass located 0.25 meters from a 1.5 kilogram mass and 0.75 meters from a 1 kilogram mass, where is the center of mass for the three-object system? All right, so we're looking down here. It was really, I thought, a little bit confusing to read through, so here it is set up. And it's kind of set up backwards, like right to left instead of left to right. We have a 1.10 kilogram mass 0.25 meters away from a 1.5 kilogram mass, and also 0.75 meters away from a 1 kilogram mass. So notice 0.5 plus 0.25 is 0.75, so that's where that's coming from. All right, the question is, where is the center of mass for the three-object system? One thing is, I think you can probably use a little bit of logic and sort of estimate where you think the center of mass is going to be. Notice this 1.5 is a lot bigger, and so that's going to be kind of throwing off the center of mass towards it a little bit. In any case, keep in your mind of where a logical place for the center of mass would be, and make sure at the end that you can compare that and it's going to make sense. Okay, then I have 3 steps here for you to follow of how should you even do this? How do you go about doing this? Well, first of all, we're going to pick a 0 location from which to measure the distances. It helps if there is no mass located at this point. Draw the location of your 0 point on the figure. So we want to pick a place where there is no mass. We might also want to pick a place that's just easy to do mathematically. And so what I'm thinking is maybe pick this as my 0 point. And if that's my 0 point, then from here to here is 0.25 of a meter. And then here to here is another 0.25 of a meter. And then here to here is another 0.25 of a meter. And so that way we've just split it up easy mathematically. It's not the middle. I know it's not the middle, but I wanted to pick somewhere that was easy to do mathematically and that had no mass at it. Okay, so that's my 0 point. Step 2, set up a center of mass equation using the 0 location you just selected. Okay, this is the center of mass equation, so I'm going to use this equation. All right, in my center of mass equation, the bottom part is just the different masses. So I've added up all of the masses. I've put those into the bottom. In my numerator, I need my mass times my distance. And when I say distance, I'm talking about the distance away from the 0 that I just had. So in my numerator, I have my first, I'm just starting at the left. First one is 1 kilogram. It is 0.25 meters away from the 0 location. I have a 1.5 kilogram. It is 0.25 meters away from the 0 location. And I have 1.1 kilograms, which is 0.5 meters away from the 0 location. And by 0.5, I'm adding this 0.25 and this 0.25. Now another thing to notice is like a number line. If this is a 0 on my number line, this 1 kilogram is actually a -1, right? Because torque-wise, this one's going to be pulling this way, and these are going to be pulling this way. So this one I'm going to say is negative. It's in the left-hand side, so that's going to be my negative. So keep that in mind, that the one, you're going to have different sides of the zero, which is like different sides of your number line. So you need to have some negatives in there. Okay, I am going to add all of these up and see what I get when I add them up. First of all, just a mistake I made here. I said 2.5. It should be 0.25. So make sure you change that to 0.25. And so then when I add my numerators together, I get 0.675 kilogram meters. When I add my denominators together, I get 3.6 kilograms. I divide that and I get 0.1875 meters. Okay, what in the world does that mean? What that means is the center of mass is 0.1875 meters from my 0 point. And remember, my 0 point was arbitrarily selected. I could have put it anywhere, basically anywhere that there wasn't a mass. And so that's how far it is from the 0 point. Okay, well, my 0 point was, again, random, but it was 0.25 meters away. If we look at this, one thing is it's a positive number. Okay, that's one thing. Secondly, we had discussed, think in your mind where you logically think it would be. I'm going to say the center of mass is approximately here. I made a little fulcrum there, but I'm going to say that's my center of mass, right? I mean, does that logically make sense to you as you look at this? It might even be a little bit more over farther to the right. It's 0.1875 meters away from my 0 point. My 0 point was already at the 0.25 meter mark. So I need to add 0.1875 plus 0.25. And so if I add those numbers together, I get 0.4375 meters. Where is that? Well, it's from the left end. I need to just, explain where I'm measuring it from. So it's from the left end. So it was 0.25 from here to here, another 0.1875 to here, and that gets me to 0.4375 from the end. Remember that our whole number line or axis or whatever you want to call it was 0.75 meters. And so again, that larger mass is drawing the center of mass over to the right a little bit. It's not in the middle. It's a little bit farther to the right than the middle would be. Okay, so that's how you do center of mass when you're just basically in one dimension, right? We're just on a single axis. This next question is, well, what if we are in the two-dimensional? And I know it looks three-dimensional, but if we look at the question, we'll find out that it's actually two-dimensional. Because what we have going on here is that we have a pallet, and they're saying the pallet itself has negligible mass, so we don't need to consider the mass in the pallet. It has a load of identical cases, with each side length 1 meter and a mass of 2 kilograms. So these are all the same, whatever they are. Apparently they're cans of tomato sauce. Find the center of gravity in the horizontal plane so that a crane operator can pick up the load without tipping it. So in the horizontal plane, so we need to have a forklift come in here and lift it up without it toppling over from side to side. That's what we're trying to find. So we're trying to find the center of mass in that horizontal plane. The horizontal plane being the pallet itself. So we are wanting it in the x direction, but we're also wanting it in the y direction because we don't want it to, flop forward or backward either. We don't want to tip our tomatoes. So let's call this the x direction and let's call this the y direction. The up and down would be the z direction. We don't care about that right now. We're just concerned about the x and y direction. We're looking at the pallet only. So in order to find the center of mass, what we need to do is we need to do two things. That is, we need to find the center of mass in the x direction. We also need to find the center of mass in the y direction. So we're going to have to look at this and figure this out. Okay, so just like before, where we had to decide where our center of mass was going to be, or our 0 point was going to be, let's just say that our 0 point is here. That's like at the origin, basically. So this is our origin, this is our 0 point. We stuck with the qualification that is up here, which it says it helps if there is no mass located at this point. So that's why I'm choosing this as my 0 point, because there's no mass there, and because it's on a corner, like I said, it's like the origin, so it's going to be a little bit easier to measure things from. So let's stick with the x direction. Going in the x direction, what do we have and where are they? Because we need our x for our mass, we need our distance as well. Each one of these has a side length of 1 meter. So in other words, the center of it is going to be at 0.5 meter. And the center of this one is going to be at 1.5 meters. And the center of this one is going to be at 2.5 meters. Okay, that's how far away each one is. Well, how many do we have at the 1 meter or the half meter mark? Well, we've got 2 boxes. Each box is 2 kilograms. So that means we have 4 kilograms at 0.5 meters away. If we look at the next line, again, sticking in the x direction, we have 1, 2, 3, right? Do you see all 3 of them? And each one is 2 kilograms, so that's a total of 6 kilograms. And they are located at the 1.5 meter mark. And then we have 1, 2, 3, 4, 5, 2 kilograms each, that's 10 kilograms, located at the 2.5 meter mark. Again, that 2.5 is because it went over 1, 2, and a half to get to the center of mass, okay? And in the denominator, we put all of the masses all together, so that's a 4 kilogram plus a 6 kilogram plus a 10 kilogram. So we need to take a second with our calculator and figure that. So take a second with your calculator, work that out, and see what does that simplify to. Okay, that should give us 1.8. 1.8 what? Well, 1.8 meters from the 0 point. So we're going to calculate over 1.8 meters. And again, that makes sense. It's farther than halfway because that's where, look, all the mass is over there. Okay, so that's where our center of mass is going to be farther to the left. So it's 1.8 meters from the 0 point. Now we need to do the same thing in the y direction. So we're measuring from this y point, and now we're, looking along this axis. So the first thing that we have is we have 1 box, and again, it's 0.5 meters away. Then we go to our next row. Our next row is here. We only have 2 boxes here. That's 4 kilograms at 1.5 meters away. And then lastly, we're going to be at 2.5 meters away. And we have 1, 2, 3, 4, 5, 6, 7. That's 14 kilograms at 2.5 meters away. And so that gives us 2 kilograms, 4 kilograms, and 14 kilograms for a total, should be the same total as up here. And it is. It comes up to 20 kilograms in the denominator, just like it was 20 kilograms in this denominator. Go ahead and use your calculator and calculate this out. All right, so we add those together and we get a 2.1 meters away from the 0 point. I tried to draw that on here and I'm not sure if it even helped at all. But if you can see this in the 2-dimensional plane rather than the 3-dimensional, that's where your center of mass would be. I tried to go over 1.8 meters in the x direction and over 2.1 meters in the y direction, and it's going to be there is the center of mass. And again, important because then the crane operator can adjust and knows what to expect when they pick up the pallet. So that's how you find center of mass in 2 dimensions. The first example was finding center of mass in 1 direction. The second example is finding center of mass in 2 directions. We will do some examples in class, some activities that involve finding center of mass both in the 1 dimension and in the 2 dimensions.